Michael, thanks for coming on. Really appreciate you taking the time to have a conversation with me. Would you mind telling us a little bit about yourself before we get started?
Hi, folks. Yeah, my name is Mike Behe. I'm a professor of biochemistry at Lehigh University in Pennsylvania. I guess I'm on the show because I've written a few books advocating for something called intelligent design, which is that a good explanation for what we find at the molecular and cellular foundation of life is the result of choice of purposeful intelligent design rather than, say, Darwinian evolution um, or some other mechanistic cause.
Cool. And could you tell me some of the reasons you believe that we can infer intelligent design from certain things and why that is a better explanation than a natural cause or an unknown natural cause?
Sure. When we infer design, we infer that a mind has acted when we see a purposeful arrangement of parts. That is, when we see things that have been put together so that they achieve some purpose or some end. We cannot read minds, and so the only way that we can tell that another mind has acted is by seeing the effects that that mind has produced. And the parts that can be arranged can be pretty much anything. The simplest examples are, say, sounds. When we arrange sounds into words and words into sentences and so on, we do that for a purpose. And we recognize that uh, when we hear purposeful sounds, then we infer an intelligence. Same thing with writing. Same thing with machinery. So yeah, the one facet of rationality is our ability to know that other minds exist. Otherwise, we might think that we're the only mind in the universe. And we do that through, as I said, through their action. So it's through a purposeful arrangement of parts.
Could you give me some examples? How do we look at certain design or purposeful arrangement of parts and infer intelligence in general? Because I understand how we can do it for humans. Like if I see Mount Rushmore, that's clearly I can infer a human did that, or I can see cave paintings, a human did that. But when looking at
Yeah.
celestial bodies or particles or chemistry or biology, I don't see how those things are analogous in such a way that we can infer design by looking at those things unless we do some kind of analogy to human design.
Well, you can ask yourselves, how do we know that humans design things? For example, uh, if you see somebody sitting, humans do a lot of things that you would not think were all that purposeful. We burp, we scratch our bellies, we walk along kind of aimlessly, or we can do something like build a mousetrap. And in the latter case, we say, hey, the person who did that is intelligent. The guy sitting on the curb scratching his belly, I'm not quite sure if he's intelligent or not. So the way that we infer intelligence, even for humans, is to see what they can do. So when we do see Mount Rushmore, well, that's we can infer that whoever made that thing is pretty intelligent or pretty skilled. Whenever we see somebody who can make a car or a computer, we infer intelligence from that as well. And I should point out that it's not necessarily that we know these things were made by humans that we infer that they were intelligently designed. If some space expedition went to another planet and landed there and found something like Mount Rushmore, they would be strongly they would strongly suspect that it was in fact purposely designed because they see a purposeful arrangement of parts. If somebody from another country who had never heard of Mount Rushmore kind of walks around and uh, turns a curve and suddenly comes upon it, they immediately recognize that it was designed. But for all they know, it might have been made by space aliens who came to Earth earlier, or it might have been made millions of years ago, or some such thing. You need other information to decide when it was designed, but you immediately recognize the design in the purposeful arrangement of parts in a system. Now, if they okay, so you ask about, okay, well, that's in macro systems. How can we tell about living systems? Well, from a long time ago, I'm no philosopher or historian, but I read that back in the day, even Greek philosophers inferred that there was purpose behind nature, and it was pretty much for the same reason uh, that I just discussed. We infer design because they saw a purposeful arrangement of parts. They would see that things in nature followed an order and it seemed purposeful. They saw that organisms in living systems were purposefully adapted to their environment. And so they thought, well, hey, the only things that have purposes are minds. And so it seems that there's a mind behind nature. And that same argument has been used throughout history. And I guess it reached its zenith with William Paley's book on natural theology, where he made the famous watchmaker analogy about coming across a watch in a field, and you'd immediately know it was designed, the product of a mind, because you'd see how the parts were arranged for a purpose. And then Paley, went on to say that, well, lots of things in living systems are arranged for purposes too, and even more spectacularly than watches. For example, the eye. And since that time, well, of course, then Darwin came along in 1859 and proposed random mutation and natural selection as an alternative explanation for design. Uh, I'm skeptical of that, as you know, and I'll go into that later. But the progress of biology since Paley's day, or since the early 1900s, has been to show greater and greater and greater organization, greater and greater and greater purpose at lower and lower and lower levels of life, so that at the foundational level of life, at the cellular and molecular levels, we see spectacular, purposeful systems, even more impressive than the eyeball. So, since we reason from a purposeful arrangement of parts to the action of a mind, as I've argued, and since we have discovered that even at the foundation of life, and since we have no other good explanation for it, Darwinian claims notwithstanding, then I argued we're justified in concluding that, in fact, the foundation of life too is designed.
So one thing that comes to mind is that a mind itself would be a purposeful arrangement of parts. And so if you were to infer that anything, particularly like Mount Rushmore or whatever, had a purposeful arrangement of parts, and that was created by a mind, then you would also have to infer that the mind was a purposeful arrangement of parts, and then it must have a designer. And so you lead this infinite regress argument that there's no actual way to posit a designer of any kind without actually positing a more complicated explanation of the hypothesis than simply saying it was an unknown natural process. So, like if I said Mount Rushmore was a result of an unknown natural process, um, it's possible. There's no logical contradiction there, but that seems to be equally as improbable as saying it was an unknown kind of designer. So, if I said it was a designer that was a product of evolution, since we have a decent, from a naturalist perspective, as I believe that humans evolved. If I said that a evolved being created this, because I already have past evidence of evolved beings, that seems rational. But if I said there was some unknown force that created a mind and that mind created this feature, then I must necessarily infer that that mind has a designer and that mind has a designer and that mind has a designer with a potential infinite regress. And so I see a problem with the argument for design here that any functions, any object we have that has a purposeful design would necessarily have to be created by something that would also be a purposeful design.
Well, yeah, those are interesting points, and I've heard them mentioned before. And again, I'm a simple biochemist. I'm not a philosopher or historian or anything like that. So, you know, these the argument I take the argument proximally. Okay, we see these molecular machines in the cell. Hey, they're very strongly purposefully they have very strong purposes. They are arranged so that they can perform functions, and that's how we detect design. That shows the work of a mind. Okay, who's this mind? Is there an infinite regress of mind? Maybe there is. What do I care? I'm a biochemist. In the same way, if I see a mouse trap, or in your case, say Mount Rushmore, you say, well, humans designed that. Well, okay, humans, but who designed humans? What? How did they get their minds? How do their minds work? Well, I don't know, but we don't withhold the judgment that Mount Rushmore was designed because we can't because we can't explain where the human mind came from. So I think we're still justified in concluding that biological systems were purposely designed, uh, even if philosophy or somebody else has a problem in trying to extend this much further than the evidence from which we reach the conclusion. The second thing I'm not sure of, and again, I'm not a philosopher, is that you say, well, minds are purposeful arrangement of parts. Well, I don't know that's the case because I don't know and I haven't read anything about who knows what a mind is and how it works and how we decide stuff and all sorts of things like that. So for all I know, and I've seen, I can't evaluate, again, not a philosopher. I've seen people argue that, minds are not material things, that they can be simple. Maybe they depend on certain parts, but I think that argument that minds require parts themselves is shaky because we don't know what minds actually are.
But couldn't we say the same thing about anything that you see in the universe that you think has design? We could be like, that is a anthropocentric fallacy of some kind, where we see design, but it's not there. Like Newton famously was trying to calculate the orbits of the planets in the solar system. He said it's so complicated, it can't be done by anything but a god. It must be some complicated arrangement of parts, essentially. He's using the same kind of argument here. But that was false. Laplace came along and just calculated it quite easily and just realized Newton was wrong. And so couldn't things like organizations of cells, evolutionary biology, be fully explained by not necessarily known natural processes, but an unknown natural process? Right now, given the natural processes that we do know about, the probability seems low to make different kinds of mutations that are beneficial. But there could just be another unknown natural process we don't know about. And positing such a thing seems a much simpler, more elegant solution than to say that it was designed by a mind. Whereas, of course, if we saw a BMW on Mars, I would say, yes, that's probably designed by a mind.
Oh, why? Why would you say that?
Analogy to human design. We know humans design BMWs. And so if there is a process out there, an object that is something we only see designed by humans and we see no natural processes that can create the parts for such a thing, then it's rational to infer that a mind would design it. But I don't think that's the
What if you
case.
saw a flying saucer on Mars? Humans haven't designed flying saucers.
Well, I actually would think that is actually comparable to a car, because you'd say, well, it seems like it's a bubble that creates an atmosphere to protect an organism from space. It has joysticks, it has chairs. So we would essentially just be doing the exact same thing as a BMW, saying, oh, these features that we see are something that a object like us designs.
Okay, an object like us designs. And so you're saying that an intelligent being designs that. So, well, suppose we put together a machine which is really complicated, more than we could put together. Say a real advanced machine, a teleporter or something like that, which is far beyond human capability. Would you say that if it got far beyond human capability to put it together, then we would reach a point where we would say, oh, it must not be designed because it's too advanced for a human capability?
No, I'd say that if we see other natural processes that can cause similar or analogous phenomenon, then that point we would say it's definitely not design. There's no reason to infer design. So, like a solar system is beyond human design. We can't design solar systems. We can't move stars around, but we don't think it's designed. We think that, oh, gravity did it. Gravity and different kinds of forces in the universe did it, because we see forces in the universe that can create this phenomenon, no matter how grand it may be. And so if we can have an example of a force that already does the thing that we're looking at, and you say, yep, that's probably explained by this force we already have.
Yeah, well, okay, that's fine with gravity, and I wasn't talking about that. I was trying to say something more about machinery, such as a Star Trek transporter or some such thing, which, say, astronauts discovered on another planet and which was beyond human technology, and we had a hard time figuring out how it worked. So I'm just wondering if you're saying that if it's beyond human technology or maybe uses stuff we never thought about, whether you could still determine that that was designed, or would there be a point at which you say, no, that's too advanced for us, so therefore it must be a natural process?
Well, no, I think that the information of saying that it's beyond our technology tells us nothing one way or the other of whether or not it was designed. What we would need to do is look at the phenomenon in nature and say, is there something that accounts for this? Like teleporters, like there is a natural account for that. It's black holes. Black holes could be a teleporter, warp, like Einstein-Rosen bridge kind of a thing. So we could see a teleporter and not be able to explain it and say that is fully explained by natural processes. And if someone inferred prior to this that it must have been designed, they would potentially be wrong, because there is a natural process that could potentially explain the data.
Okay, and if you saw an outboard motor, you would not think that that was explained by being a black hole or gravity or some force of nature. You would ascribe it to human design, I'm sure. So
Sure.
if you saw an outboard motor in the cell, as I've written about, of course, the bacterial flagellum, tell me again why you would withhold a judgment of design in that case.
Well, in that case, I'd say it definitely wasn't designed, because we have a model of evolution that makes novel predictions that has made significant progress in the field. And that hypothesis has more successful results in making novel predictions and progress in the field than any other hypothesis that I am aware of. And so I'd say that that is fully explained by the data of evolution. And because we know of, even if suppose evolution didn't fully explain the flagella, I would say that because we have a strong background knowledge in processes that can produce extremely similar features through mutation and evolution and genetic drift and all the different things that we know are features of evolution, I'd say that there's probably more of those that we don't know of yet. And with the addition of more of those that we haven't yet discovered, that would explain the flagella, or that would be a more plausible explanation of the flagella than a mind because we already have this thing that exists there, the evolutionary processes, which explain a large portion of the data we're looking at. And with the addition of a few more precision making features, we could get the entirety of the data explained. And that requires less of an assertion than the addition of an entire new mind, which seems to be a much more complicated thing. So it'd be like explaining a mystery with a greater mystery.
Okay. Well, of course, you're entering my bailiwick here. And over the past 25 years, I've written a few books specifically making the argument that, in fact, we do not know that evolution could make such things, that assertions to the contrary are pretty much just that. They're assumptions that evolution makes whatever we discovered, that Darwin proposed evolution by random changes and natural selection, and gave arguments that it might explain things such as eyeballs and so on, but that it was a proposal. And since 1859, it has not been supported. And I've also written that it's crucial to distinguish different concepts in what is broadly called evolution. And two concepts that are particularly pertinent are the idea of common descent. That is, that organisms living today have descended with modification from organisms in the misty past, and the mechanism of evolution. That is, what in the world could cause such fantastic transformations to occur. And that evidence that things have descended is oftentimes confused as evidence that the cause of changes are random mutation and natural selection. But as I've written, Darwin, of course, had no idea of the cellular and molecular foundation of life. He knew nothing about genetics, didn't know what the mechanism of inheritance was. Even the folks who came up with the neo-Darwinian synthesis in the mid-20th century did so in innocence, not knowing anything about what were the genetic factors, what molecular machinery was like. And that now that we have found out, it seems that Darwin's idea does not work at the molecular level. It does not work to construct molecular machinery. And I've written a whole, again, a bunch of books on this. And I have pointed out that if you look in the scientific literature and you ask yourself, well, who has explained exactly how, say, something like a flagellum could come about in any testable detail, or who has done experiments showing that if you grow a lot of organisms, say bacteria, for many, many thousands of generations, who has seen new, complex, sophisticated systems come about, such as the kind that are common in the cell? Turns out nobody has. And so I agree with you that evolution, quote unquote, has a lot going for it, in the sense that we see that organisms are related, and we can follow genes, and we can look at evidence for common descent. But again, evidence for common descent is not evidence for Darwin's mechanism. I would say we have precious little evidence that Darwin's mechanism, or any undirected mechanism, can explain the molecular machinery of the cell. And as a matter of fact, as I've written in my latest book, Darwin Devolves, we have great evidence that Darwin's mechanism is actually devolutionary. That is, it degrades genes, it burns genetic information as fuel for adaptation. So when you say that you would conclude strongly that the flagellum is the product is not the product of a mind. Do you have any replies to any of these objections, or are you just essentially taking the word of the scientific community at large for that?
Well, I'd say that they're false. Like I see from my research in the field, it seems like there are many different kinds of additions that are not in any way degradations to genes, genetic drift, sexual selection, recombination. There's all kinds of things that produce beneficial mutations, gene flow, epigenetics, niche construction. And there's like big examples of additions like placentas being evolving inside of lizards that previously didn't have them. That seems like that can't be a reduction. It's literally just a new thing. But even if we granted that and said, sure, it seems like a more plausible explanation of the data is given that we've, since the time of Darwin, discovered all these new features that add in more abilities to explain more phenomenon in DNA and evolution. And that was a prediction made by evolutionary models, not Darwin specifically. He didn't know about any of these things, but evolutionary models were the ones that predicted and discovered these things before we knew them. They were able to use their hypothesis to make a prediction about reality that we didn't know yet, confirm that prediction through testable results, and they've made hundreds of thousands of such cases. That this model has a strong explanatory power. It can explain the data, it makes predictions, it is extremely useful. Whereas if we take the hypothesis, the alternative hypothesis of design, it doesn't seem to have ever been able to do that. Even if I include like the 10 predictions that were included in Dymski's work. Those seem very small by comparison of the tens of thousands, hundreds of thousands of predictions made by all of the things done in evolution that have been proved successfully in the lab repeatedly. And so it seems like a simpler, more rational explanation would be is that there are more of these that we have yet to discover because we discover a new one every few years, and that would further explain the data. And so even though from the time of Darwin explaining this would be very, very difficult and hard to understand, each successive discovery we have in the field makes it easier to understand. It's still difficult to understand, but it seems like the more rational explanation here is that there are more of these features we haven't discovered yet that would explain the data, as we do see genes in these features creating essentially new information. Why would that be a less plausible explanation than saying a entire other mind is required to explain this data?
Well, because we don't see these processes creating new information, and I think essentially you've been reading advocates publications for some of these things, and none of them can explain the types of systems that I have discussed in my book as problems for Darwin's theory. And in my latest book, Darwin Devolves, I spent 3 chapters going over alternative evolutionary explanations other than what is called standard Darwinian theory. That is complexity theory and symbiosis and epigenetics and niche construction and all sorts of things like that. And they're all kind of neat and they're entertaining ideas, but none of them, 0 of them, even try to explain complex functional systems like, say, the eyeball. That, if you read standard textbooks, people will say, why Darwin explained the eyeball that William Paley had said was problematic for non-intelligent explanation. But he didn't, of course. He just pointed to a series of, superficially similar looking structures and said, well, maybe that this could be produced by random mutation and natural selection. And I've written, of course, 25 years ago, I wrote why I think that's not true and that Darwin knew nothing about the molecular level of life. And when you look at the molecular level, it's horrendously sophisticated and complicated. And the point here is that you talk about newish ideas in evolutionary theory. None of them try to explain the eye. None of them try to explain the bacterial flagellum. None of them try to explain Paley's watch. They all have decent, they all have, you know, interesting points to talk about. But the crucial question of how do complex functional systems arise, such as watches, such as eyeballs, such as bacterial flagellum, is not addressed by these folks. And I should say, I disagree about evaluating the what seems more likely of whether a new natural process might pop up somewhere down the road in the future, or whether we are justified in concluding design, just by pointing out that since time immemorial, since we've had written records, people have taken the purposeful arrangement of parts, the essentially fitness of organisms to their environment as evidence of design, you know, from the old Greek philosophers throughout the ages up till William Paley. And it's only been since Darwin that people have said, wait, maybe there are some law or other that can explain this. And in the meantime, since Darwin, as science advanced, we've uncovered greater and greater and greater and greater complexity. And we have seen, as I've argued, that this is a very, very poor fit for Darwin's theory. That, and if you look at the literature, nobody has actually successfully used Darwin's theory to explain any of this, keeping in mind the difference between the mechanism of evolution and common descent. And none of the other alternative evolutionary explanations that have been touted recently, which have been proposed because of the failure of Darwin's ideas to explain a number of different things. None of the alternatives is successful at explaining such things either. So I think folks throughout history have been correct that we are, in fact, seeing the work of a mind here.
So, in the context of history, prior to the Greeks, most people believed the world was flat. I don't think that the fact that we have intuitions that most humans share is a good reason to trust those intuitions. I think it's absolutely the opposite. And so, I think the reason that we now defer to natural processes is because that intuition has been proven false pretty consistently. I think pretty much every time we've ever tested it, it's been false, with the exception of human design. And so the vast majority of it was wrong. So like Zeus, Thor, leprechauns, fairies, ghosts, all of those have been tested and proven false. But we still get the exact same intuition that we see something, it seems like it's an intentional design, and we get this feeling, this intuition that it was designed, and it's just wrong like every time. So that's not doesn't seem like a reliable methodology we should use. And in the context of evolution, when we compare the two hypotheses, it seems like the evolutionary hypothesis is, again, making successful novel predictions that can explain the data. Now, whether I think it has fully explained the eye, I think that's a solved problem in the consensus of biology. But even if you disagree and you think that it's not, I still don't understand why positing an unknown natural process here would be less preferred, given that we have lots of evidence of natural processes. So, for example, like in physics, if we see a new physics phenomenon, dark energy, dark matter, whatever is out there, you could posit a new kind of a thing like magic, but physicists are probably going to say that's probably not the best explanation. We should probably go with something like undiscovered law of physics. Why would we posit magic? It doesn't seem to make any sense. We already have lots and lots of evidence of this certain kind of phenomenon causing astronomical bodies to move. So why would we posit an entirely new entity that has no basis in evidence instead of positing a new kind of the old entity? The new kind of the old entity seems like a much more epistemically stable explanation than entire new ontologies.
Well, as you might suspect, I disagree for a couple reasons. We got tons of evidence for design in nature. As I said, design the work of a mind is seen in the purposeful arrangement of parts. That is the evidence for a mind. Minds have purposes. Other things don't have purposes. Dark energy doesn't have a purpose. I mean, it doesn't have um, it, does not strike people as the work of a mind, or gravity, simple things like this as the work of a mind. I know that people make arguments about that in relation to the universe, but for our purposes, uh, you know, throughout history, people have realized that the evidence for a design is staring there right in front of you. It's the purposeful arrangement of parts. Talking about physics, it's interesting because, as I'm sure you know, back before the 1930s, people thought that the universe was eternal and unchanging. And then when the motion of the galaxies away from each other and away from Earth was observed, that was the beginning of the Big Bang theory. And of course, rolling the Big Bang back, in reverse in your mind points to a beginning. And so that struck many people as having, perhaps philosophical and theological implications. Maybe that was the beginning of the universe, maybe even a creation event, maybe even by something outside of nature. And people hated that idea. A number of physicists wrote against it, that they did not want the Big Bang theory because it seemed to have implications they did not like. And as a matter of fact, many scientists these days still hate the Big Bang theory. In the 1980s, Nature, the premier science journal in the world, ran an editorial with the interesting title, Down with the Big Bang, in which they called the Big Bang philosophically unacceptable, and that said that it gives aid and comfort to creationists. This is, Nature. This is the leading science journal in the world. The point is that, suppose they said back then, "Hoo boy, this looks like it's pointing to some other need for some entity outside of nature, and we have no experience of that. So why don't we just try to explain these, red shifts of galaxies by some other, unknown law of physics, or by some other method? Let's push out the idea of a beginning and try to work with things we're more familiar with." If that were the case, I would say that then that science would have made a whole lot less progress than it did. But it eventually, science eventually accepted a Big Bang theory and kind of pushed aside any philosophical or other implications and worked from there. I see a very similar situation with intelligent design. We have extremely strong evidence for design in the purposeful arrangement of the molecular machinery, the genetic code, the genetic regulatory networks, all sorts of stuff in the cell. Nobody expected this. No scientists expected this. Nobody has an explanation for how it arose. Again, assertions of partisans notwithstanding. Um, and yet it's trying to be ruled out because it seems to point to places that a lot of people don't want to go. And yet I would argue that science should follow the evidence wherever it leads and let other people worry about philosophical consequences. Um, Now I've forgotten where I was headed, but I'll finish it there.
Well, yeah, so I would agree. I think we should follow the evidence wherever it leads. And I think objections in the Big Bang Theory are for the hypotheses that, like you mentioned, that there's something outside of nature. Now, that doesn't follow from the Big Bang. Definitely something outside of our universe. That does follow. That's the consensus. I would agree there 100%. I don't have much to say about editorials. I don't read many of them. So obviously they're there to get clicks. And so they're going to say the most interesting things to their audience that they can. But I would think in the context of physics, it's like with the Big Bang. If we see the Big Bang, and that is definitely the consensus in physics, the Big Bang happened, and we're trying to explain it, it seems like explaining it as a combination of known things like quantum fields or something seems to be much more plausible than saying there's an entirely new ontology of supernatural or in some kind of thing outside of nature. That seems, because there is no prior basis for such a thing, a much worse explanation than using a combination of things that have been verified to exist independent of our imagination. So it's like if we see a hoof print in the snow, we want to say what caused the hoof print. Saying a horse is always a more plausible explanation than a unicorn, because we have lots of past evidence of horses, no past evidence of unicorns, and so the horse is the more plausible explanation. And the same thing seems to apply to the Big Bang and genetics here, or evolution, or the complexity of the eye. If we want to say what explained the complexity of the eye, and we have some phenomenon that we have evidence for, such as genes, genetic drift, epigenetics, niche construction, whatever, and they do work. They do work in genetics to make changes, and they seem to be caused positive changes, like a placenta forming in a lizard for the first time ever. That seems like a positive change. You may want to define it differently, but I don't think any logical, coherent definition could define that as a deleterious mutation. And so if it can cause this kind of a change in a lizard, then it seems like there is enough useful work that can be done by these features to explain or to give us a reason to believe that this can be a basic explanation for the origin of life. And giving certain examples of things it can't explain, like obviously there's going to be thousands and thousands of things it can't explain because it's not a completed hypothesis yet. We don't have full data on it. But that just seemed to be like an argument from ignorance. Like obviously science has never been able to fully explain anything, and pointing to the things we can't explain isn't evidence for an alternative hypothesis. What you need is an alternative set of novel predictions that your hypothesis makes that can be confirmed, that are equivalent to the degree of novel predictions that the original hypothesis makes. Simply saying there are things it doesn't explain doesn't really help us at all. You need to have a different way to indicate that. And simply looking at something and thinking it's purposeful seems to be more of an intuition we have as humans, not like that there's any kind of actual purposefulness in things that we see, because we see purpose in everything, even though it's definitively not there in many cases. And so the fact that our minds are very faulty at establishing purpose seems like trying to use that as a basis to infer design is a very unreliable basis.
Okay, well, okay, a couple things. First off, you say that we see design in everything. I'll start there. I just want to make a little comment. I think that's not true. If you're walking along, say, out in the mountains or something, and you stumble across some rocks and you hit your foot against a bank of a stream or something. Okay, well, do you see design in that? Well, maybe some people who love nature might think so. But if you turn the corner and you see Mount Rushmore, you see design in a whole different way than you did with the other stuff. So I disagree with you're saying that we see design in everything. No, we might have some false positives, sure, if you see a face in the moon or something like that. But when you go back and look at the face in the moon, you can say, well, no, there was just a bunch of shadows and stuff. When you go back to Mount Rushmore and look more closely, you say, no, this is the exact place it should be if it's supposed to be a nose. And this is placed at the right place. And I can look at it from different directions and it still looks like a face. So,
well, just before you go on, I wanted to go on the toe stubbing thing. That was actually commonly seen as design, like Loki playing a trick on you, or fairy spirits playing a trick on you. So that was actually very commonly seen as design.
Okay, well, maybe, but well, that's going into things I actually have addressed, but don't want to spend my time on here. Second thing is that it's interesting to me that you confidently say that we've got explanations in hand or know of mechanisms that have a shot at making things like eyeballs and so on. And I would specifically deny that. We haven't the foggiest idea of some undirected natural mechanism, whether it's Darwin's random mutation and natural selection, whether it's sexual selection, whether it's random drift, whether it's whatever you want to say. We have no clue about that. And the one example I will point to is the best laboratory evolution experiment that has ever been done to date. And I've written about it multiple times, and that's the work of a man named Richard Lenski, who's a professor of microbiology at Michigan State University. And for listeners who haven't heard about it, for the past 30 years, Lenski's lab has been growing bacteria called E. coli in his lab, where he would grow a small flask full of bacteria overnight, and the bacteria would undergo about 6 or 7 generations that eat all the sugar in the medium, and then they'd slow down and stop. And the next morning, he or one of his grad students would come in and transfer a fraction of that culture into a fresh flask with new food and so on. Next day, after they've undergone another 6 or 7 generations, you do the same thing the next day and the next day and the next day. And currently, there are over 70,000 generations of bacteria. There have been trillions of bacteria born and died in the flasks in Richard Lenski's laboratory. And in the beginning, he saw that some bacteria in the flasks would grow faster than others. They had a change, they had a mutation that allowed them to do better in their environment. But back in the late 80s, early 90s, there wasn't the technology to track down those mutations at the molecular level where mutations happen. Mutations are, of course, changes in DNA and the proteins that it codes for. So he just studied the rate at which mutations would come along and help the bacteria improve and make it go faster and have its membrane change and the cell shape change and other things. And in the early 2000s, with the advance of technology, he was able to track down the first mutation that made a big increase in the ability of the bacteria to grow faster. And he saw that the mutation was actually the destruction of a group of genes involved in metabolism of ribose in the cell, the ribose operon. For some reason, people still don't know quite why, if you destroy that operon, it allows the bacterium to grow 10% faster than it otherwise would in his culture. 10% doesn't sound like a lot, but that means that in 10 generations, those mutants have taken over the culture. And he saw subsequent waves of mutations and improvements and growing faster. And he tracked some of them down, and they too were ones where various genes had been broken or degraded. And that helped the bacterium grow faster. And in the year, I think it was 2016, he published a definitive paper in Nature where he had 2 tables listing 37 mutations that were the most highly selected in his experiment. And of those 37 mutations, 37 degraded or destroyed the genes in which they occurred. There were 0 that were building new complex systems. So the point I try to emphasize in my book, Darwin Devolves, which came out 3 years or so ago, is that Darwin's mechanism works great, but it works by breaking or destroying pre-existing genes, and that can help an organism adapt to its environment. I start off the book with the example also of a polar bear, not just this is not just bacteria, but a polar bear. And scientists have been able to compare the genome of polar bears to grizzly bears, and they're both supposed to be descended from an ancestor a couple 100,000 years ago. And these days, it's crazy. You know, they've been able to sequence the whole genome of these animals, like falling off a log or something. But anyway, they did it specifically because they wanted to see what genes, what mutations allowed some ancestor to become a polar bear, this magnificent animal. And it turns out the most highly selected mutation was one which destroyed its ability uh, to put pigment in its fur, so turning its fur white. Hey, you can see that would help a polar bear, and it does, but you have to realize it was a degradative mutation. The next most highly selected one was one that degraded a gene involved in fat metabolism, and that kept cholesterol from accumulating in the polar bear's system. And that's good because polar bears eat a lot of fat, seal blubber. And so that helped them adapt to their new environment. Of the top 17 mutations in genes that were listed in the paper, 3/4 of them were degradative or decreased or destroyed the activity of the pre-existing gene in which they occurred. So when somebody, kind of breezily says that we know of mechanisms which can account for stuff like eyeballs and other complex systems, I disagree because, in fact, the main one that people have relied on just recently, just in the past few decades, we have discovered works not by building stuff, but by breaking stuff. And it's important to realize that it's only now, only in the past 10, 20 years, that science has acquired the ability to look at the crucial molecular level to see what exactly is going on when a mutation occurs and spreads through a population. Before, people kind of optimistically thought, well, this is really improving stuff. But now we know it can be improving stuff, but it's doing so by throwing stuff away, not by building new things. And while that's an important way for an organism to adapt to its environment, it is not an explanation for how you construct complex systems in the first place.
So I actually have the paper here of the polar bear things, and yeah, it seems like a large portion of them are benign and not damaging. I think the second one on the list is benign, third one on the list, sixth, seventh, eighth. But of those things, it seems like you said that we don't have a plausible explanation that could have a shot at explaining the eyeball. It seems like the eyeball is just a combination of DNA changes. So if we have a process that changes DNA, by definition, that would have a shot at explaining the eyeball. And so, assuming that it's deleterious, even if it is in many cases, which most seem to be benign, I think most cases are confirmed to be benign, would in fact give us a potential shot at explaining it by definition. Since it changes DNA and DNA is what causes the eyeball, by definition, it would have a shot at explaining the eyeball.
Well, I disagree. It's kind of like saying, well, okay, we have a poem by Wordsworth, and we can change things because it's just made of letters. We can change it into the Gettysburg Address or something. Yeah, well, theoretically you can, but it's got as much likelihood of occurring as the old proverbial million monkeys typing away at typewriters. if you do not have a direct route from a functional system through functional intermediates to a new and different and complex functional state, then Darwinian processes won't take you there. And there is no other process that's been proposed that would do even as well as Darwin's process. And if you do not have a process to guide you from one place to another, then it is indistinguishable from chance.
Well, I would
So,
agree, but it doesn't seem like positing a mind is a process either. And so if we're going to say that we need a process, and we're going to go based off of the simplest possible route, then positing an entire mind that is complicated enough to design this thing seems like it adds several orders of magnitude to the complexity of your argument as opposed to unknown natural process. And so I would agree with most of what you said there, but going by that logic seems to indicate that we should go with natural processes rather than design.
okay, well, I disagree, but let me say first that I would say that no, a person in your position should, in fact, say we have no clue as to how this thing could happen, rather than saying that it's more probable that a natural process produced it. Because we know of no natural process. The natural processes we look at don't do anything like this. When we have an experiment where we just let things grow to see what they do, they don't do anything like what we see in the cell. They don't build new functional complex systems. If you don't think a mind is a good explanation, well, then you should just say, well, okay, we don't know yet. Maybe later on we'll figure something out. But I don't think you should say that we should default to this, natural process on the basis of no evidence. And in the case of a mind, let me say again, we positively apprehend the action of a mind in the purposeful arrangement of parts. One has to realize when you're thinking of mechanical explanations versus intelligent explanations, you're looking in two different categories. You apprehend intelligence by purpose, which is not a force, it's not a mass, it's not a position, it's a relationship of different things to other things. Um, so asking for a mechanism whereby a mind works, yeah, we don't have a mechanism. We don't know of a mechanism. We don't know the mechanism whereby our own minds work. I agree with you that we see people doing intelligent things, and we know they're intelligent because we look at what was produced, not just because there is somebody who looks like a human. But we don't know how they do that. We don't know how somebody writes a new novel. We don't know how somebody proposes a new hypothesis in science. We don't know how minds work, even with our own species. But we do know there are minds. We do know that there is purpose. We do know that we do arrange things for reasons. And so when we see that, my argument is that we are justified in concluding that, in fact, that was the work of a mind as well.
Gotcha. We do have some questions from the audience, if you don't mind.
Oh, please. Yeah, sure.
So Pbot Stulu asks, does Mr. Behe think that there's a design purpose in cancer? Is the design of cancer evidence or perhaps of a malevolent designer?
The short answer is that from what I see, cancer is mostly the breakdown of control of design systems, not not a design system itself. That is, in most cancers, and I'm no physician, of course, most cancers I know of, what happens is that genes break. You can't keep the growth of a tissue within its necessary bounds, and generally an organism dies. So that illustrates to me that, in fact, there's whole lots of things that have to go right for an organism to live, but things can go awry. So I will say that, it's certainly true that design systems can break down, just like, say, cars can break down, and computers and TV sets and so on. And so can cells and organisms. So, I think cancer I would categorize it as a kind of a side effect of a breakdown in a design system.
I think a better example might be malaria, and malaria being drug resistant. Would that, which requires specific mutations, would that be indicative of a malevolent designer of some kind?
Okay, that's a great question. Yeah, as I imagine you realize, I wrote a book on which included that as a prominent example. Yeah, yeah. Chloroquine was a drug that was used to kill malaria, and as most people know, malaria is a deadly disease, can kill 1 million people a year, and caused by a little single-celled microbe, which is transmitted by mosquitoes. And you shouldn't blame the mosquitoes, because they get infected by the malarial parasite too, and it kills them too. But over a decade or 2 decades, malaria developed resistance to chloroquine. And it turns out, as I wrote, that people finally tracked down what the mutation was that allowed it to become resistant. And there was a particular protein in the malarial cell called a chloroquine transporter, which helped kind of pump out stuff from the malarial parasite's, stomach, quote unquote. And it required 2 mutations, 2 specific mutations in a particular protein, in order for that resistance to occur. And as I wrote in The Edge of Evolution, if you count up the numbers of Plasmodium malarial cells, it took about 10 to the 20th malarial cells. And for those who don't like exponential numbers, that's what, 100 million trillion cells, a super astronomical number, more cells than the number of stars in our galaxy and stuff. It took that many malarial cells to develop resistance to chloroquine. And when we looked to see, or when scientists looked to see, there were 2 crummy point mutations in a pre-existing protein. There was no new molecular machinery. There was nothing, no fancy. There was no fancy stuff there. Sexual selection didn't help. Gene drift didn't help. None of the newer mechanisms of evolution that people have talked about in the past few decades was anywhere to be seen. All it seemed to be 2 point mutations. And as I wrote in the book, 10 to the 20th is about the number of rolls of the dice that it would take that by chance to get those 2 mutations in a large population. So yeah, I think resistance to chloroquine developed by a classical Darwinian mechanism of random mutation and natural selection. But the point is if you need 2 things to occur, as this did, then it's the square of the likelihood of just 1 thing being required. If you need just 1 mutation for resistance to a drug, and there are plenty of drugs where that's the case in different organisms, then the odds of getting that mutation are about 1 in 10 to the 8th, 1 in 10 to the 10th. But if you need 2 at the same time, then it's the square of that, 1 in 10 to the 16th to 10 to the 20th. So I use that example uh, to say that, certainly Darwin's mechanism does work, it does important things, but it has severe limit. And if you need more than a couple mutations to occur at the same time for a selectable effect, then Darwin's mechanism quickly peters out. I went on for a while with that, but I think I I hope it addressed the question.
Gotcha. Winston's mom asks, if tomorrow morning you woke up and there was definitive proof there was no God, would that affect your moral foundations?
Well, again, I'm just a country biochemist. I'm not a theologian or philosopher or anything, and uh, uh, I would think probably would. Sure, yeah, I think so. But it would affect a lot of other things than moral foundations. In my view, I would be quite surprised, and I'd also like to wonder about what this definitive proof might be, because it is difficult for me to see what that might be.
Gotcha. Super Squid Hunk asks, have him explain the recurrent laryngeal nerve in a giraffe. How is it possible such an obviously poor design is the work of an all-powerful, all-knowing God?
Okay, I'm not an anatomist and stuff, but from what I read, recurrent laryngeal nerve is some nerve that starts in one place and it goes down and kind of loops around and then comes back. And some people have used this as an argument, saying, well, if it was designed, then it would make a short connection from its start to its finish, and therefore it's an example of poor design, and therefore God is not, there that it's unlikely that it was designed. Well, first of all, I can say a few things about this. That this isn't theological argument. Number one, it's a theological argument. The theological argument is that God wouldn't have done it this way. And it's always a bad idea for scientists who uh, base their conclusions on theological arguments. We're supposed to explain the data, see what's going on, and see what's the best explanation. A second thing is that it's an argument from ignorance. It says, I know of no reason why this nerve should go down this long path and then come back the other way and reconnect when I would have designed it this way. So therefore, since I see no reason for it, therefore it has no reason, therefore it was not designed. Okay, that's generally considered not to be good reasoning. Third is, let's see, what's my
Well,
third?
just a quick question there. Isn't that the same thing you're doing when you say you see design? Is that if it looks at it, you looks like it, how you would design it, therefore it was designed? Isn't that the same thing as saying, looking at it and saying, it doesn't look like how I designed it, therefore it wasn't designed?
No, no. I'm not saying that something is designed if that's the way I would do it. I'm saying if there is a purposeful arrangement of parts, then we perceive design. So, for example, if a, a car has rear wheel drive, I wouldn't design something with rear wheel drive. I think front wheel drive is better. So, nonetheless, I recognize that cars with rear wheel drive are designed. I might not design a nuclear weapon, that's a bad thing, but nonetheless, I recognize that it was designed. The only question for science is that can uh, mechanical processes explain how the laryngeal nerve occurred? And not only that, but how, say, nerves arose. And the short answer is that if it can, nobody has done so. And there's strong reasons, essentially for the same reasons I talked about earlier, to think that it could not. Another point is that you've got to be careful in confusing a couple of things. One is evidence for common descent, and the other is evidence for Darwin's mechanism. It may be the case that the placement of the laryngeal nerve in giraffes is, some ancestor of it had it in a particular place, and then giraffes developed, and uh, and that it uh, resulted in the circuitous route. But that's only evidence for common descent or a historical constraint. It's not evidence that um, the original nerve could have arisen by an unintelligent processes. It's not evidence that other changes in the giraffe, like long necks and stuff that did occur over time, were driven by random processes. It's only evidence that, well, maybe there was a historical constraint. It might be evidence against, say, puff of smoke creation, where you zap a giraffe into being at once. Maybe it is, but it's not. It's not evidence of say against something like guided evolution or directed evolution. One last point I'd like to make is that, again, I'm not an anatomist or anything like that, but I've read other people write that, in fact, along its merry way, as the laryngeal nerve goes down and back, it makes a number of other connections. It innervates other tissues too. So that the unstated assumption that there is no purpose for it to go down and come back might not be correct. It might actually be doing something for the giraffe that we do not fully appreciate. And that occurs time and time and time again in biology. It's oftentimes the case that when people see something and they don't know what it's for, they think, well, it's probably a historical accident, or it's just a supporting structure, or, probably nothing important. Back in the 1920s, DNA was thought to be just a structural material in the cell because people couldn't sequence it. It was thought to be a simple repetitive polymer of A, C, G, and T. People thought it wasn't all that important. A lot of regions in DNA these days that do not code for proteins, people originally thought, well, they probably don't have any purpose whatsoever. And the story of much of biology in the past 10, 20 years is that the more people look, the more functions that are seen in such places. So yeah, it's always a problem to conclude that just because you don't know what something is doing, that therefore it is not doing anything. And I think that laryngeal nerve argument is in danger of doing that.
Gotcha. Aaron Summerhill asks, different phenotypes can be generated with no changes in DNA at all. Wouldn't that be an argument against the deleterious argument?
I'm not quite sure. I don't follow why that would be. Okay, yeah, you're certainly true that different phenotypes can be generated without changes at all in DNA sequences. Even single organisms, like butterflies. Butterflies have larval stages and they grow up like caterpillars and they change into butterflies, and it's all with the very same DNA. But I'm not quite sure why that's helps with an evolutionary or Darwinian point of view. Clearly, the information for doing that for both phenotypes was already present in the DNA, and that's at least one more phenotype than we would expect to see in an organism, at least as far as I can see. That, it's certainly a indication that things are maybe more complicated than we appreciate, but I don't see how that argues that that it solves a problem.
Gotcha. Peabot Thulu Super Chat, thank you, asks, can you ask the gentleman if his theory lends credence to creation according to the Quran?
Yeah, sure, you can ask me. And I'll say I haven't the foggiest idea. I'm afraid I haven't read the Quran, and so I don't know.
Gotcha. Aaron asks another question. Why do birds have phonematic hollow bones, even ones that can't fly like ostriches, but bats have solid mammalian bones and can fly if birds' bones are designed for flight?
Well, that's an excellent question. Okay, so pneumatic hollow bones are essentially, bones that are hollow, air can go through them, and they make the bones lighter, and it's thought that helps the birds to fly. So why do ostriches have hollow bones even though they can't fly? Well, good question. One reason might be that they're descended from birds that can fly. Okay, so that's evidence for common descent if you think that's the case. But it doesn't say where the ability to fly came from. It doesn't say where the ability to make bones that are hollow and light for flight came from. It just says that this organism kind of resembles that one, so maybe they're related. Okay, I'll go along with that. The interesting question is, bats have solid mammalian bones and still can fly. And I'm guessing maybe the implied question is, why weren't bats given these spiffy pneumatic hollow bones to help them fly? And the short answer is I haven't the foggiest idea. But, bats seem to fly just fine. You can say that that might be evidence that they are not descended from birds. That's fine with me too. But you can't, none of this goes to the question of how could these fantastic changes have occurred? If bats have solid bones, great. How'd they get them? If bats can fly, wonderful. How'd that happen? If ostriches can't fly, well, maybe they descended from birds that can fly, but then that just means they lost a trait. Okay, but that doesn't explain the trait that they lost. It doesn't explain flight. So again, these are great questions, very interesting, but they just go to the idea of common descent. They don't go to the idea of the mechanism of evolution.
Gotcha. Tater N asks, I don't understand why he thinks it requires an intervention from a god or a mind designer, and why natural processes can't be how the mind did it, and why we're discovering how God did it with the natural processes. I believe he's a Christian.
Okay, yeah, that's great. Actually, that's what I used to think. I was, I'm a Catholic, a Roman Catholic. I've written that in my books, and I went to parochial schools, and we were taught Darwin's theory of evolution in parochial school, and we were taught that, hey, God made the laws of the universe, and if he wanted to make life, then by the unfolding of those laws, who are we to tell him otherwise? And that seemed perfectly fine to me. What do I care how God, decides to make life? But then later on, after reading some stuff, the explanation I was taught in schools about how natural processes did make life or could make life was seen, or I saw it to have a lot of problems and a lot of question begging and a lot of counter evidence too. And the more and more as time passes and science advances, those problems have become more and more acute. So I agree. I mean, I'm no theologian again, but if God wants to make life by natural processes, go for it. I'm just happy to be here. But from the evidence from biochemistry and biology in general, it doesn't look like just simple natural laws, akin to gravity and electromagnetism and stuff like that. They're just not enough to explain the purposeful structures that we find in life.
Gotcha. Big Bad Mama asks, why is intelligent design largely ignored by the global academic community?
Okay, well, that's a good question. Tell you the truth, when I wrote Darwin's Black Box 25 years ago, I thought people would read it and say, "Well, of course, why didn't I think of that? That's so obvious," and would agree with me. And that didn't happen. And of course, as you know, much of the scientific community is kind of hostile to intelligent design. But also, if you read my books and responses and stuff, you see that none of the academic community has good answers to the questions that I raised or to the problems that face Darwinism. So, heck, me, as you might expect, I conclude that in fact people just don't want intelligent design to be true, or at least many people don't want intelligent design to be true. As a matter of fact, I had a philosopher tell me that directly. His name is what's his name? Thomas at New York University. I forgot. I'm terrible with names, but anyway, he said he has written in some of his books that he does not want there to be a God. He does not want something like design, or well, he doesn't care about design, but he doesn't want there to be a God. And a lot of people, not him, but a lot of people think that design points in that direction. So they try to avoid that. Additionally, for historical reason, there's been bad blood between biology and a lot of religious folks because people back in the day took umbrage with Darwin's theory, and people who did not like religion, especially scientists who didn't like religion, have used it as a stick to beat religious people with. So there are these extra scientific, sociological reasons that I think intelligent design is not popular in academia. But heck, I'm playing the long game here, and I'm serenely confident that in the long run, design will win out. And the reason is not because anything I have written or anybody else I know has written, but because that's where the evidence is going. As biology progresses, things are getting more and more sophisticated, more and more complex. Darwin's mechanism is seen to explain less and less. So you can't ignore the data forever, I think. I might be wrong with that.
Gotcha. We have been going for about an hour and a half. Really appreciate you coming on. It was a great conversation. Do you want to give any links or references where people can find out more about your work?
I think there's a website that somebody set up for me. It's michaelbehe.com, and there's some short videos and stuff there that give you an easy introduction into some ideas. And of course, you can just look up my name on amazon.com. And I've written 3 major books. And if you're interested in this, I would start with the first book, Darwin's Black Box, kind of lays out some groundwork. And then I'd go to the latest book called Darwin Devolves, because I think that's got some interesting points to make.
Awesome. Thanks again for coming on. I really appreciate it. I hope you have a wonderful rest of your day.
Thanks very much. Thanks for having me.